My name is Michelle Ruley.
I'm Dylan Rose.
This presentation is brought to you by the Amalfi Research Experience for Undergraduates, sponsored by the National Science Foundation.
As more data becomes available, existing machine learning techniques are unable to keep up with these big data problems.
Big data refers to any problem so big that it must be handled on the cloud. To understand the scale of big data, there's three driving forces.
Volume of data refers to how big the problem is. For example, the NSA is building a facility capable of storing around 5 zettabytes.
Velocity of data refers to how quickly data can be read in and processed. Google can process upwards of 24 petabytes a day.
Data variety describes how many different formats your data comes in. If you're gathering data from the internet, your imagination is the limit. Our solution is to implement an existing machine learning technique in a cloud environment. The key to our solution is leveraging the MapReduce framework to achieve fast algorithm runtimes on large input datasets.
In order to provide a start-to-finish, enterprise-scale solution, we need to implement 3 successive steps. The first step is to read an existing dataset. Data can come in any input format, from images to raw text.
The second step is to vectorize the input, or represent it in a mathematical fashion which computers can understand. What we have here is a textual dataset being mapped onto a vector based on the frequency of each term in the document. These vectors are mapped onto a matrix of pairwise distances, which we call the similarity matrix. This serves as the input for our algorithm. The algorithm we are implementing, Hierarchical Affinity Propagation, is an exemplar-based clustering algorithm. This means that every data point can potentially be selected as an exemplar, or cluster center.
During execution of the algorithm, data nodes communicate by sending each other messages which will decide the eventual exemplars. This same process occurs on multiple levels, resulting in the hierarchy of clusters. Once we've extracted clusters, we now know a little bit more about the underlying structure or patterns that exist within the data.
In these results, the clustered groups represent clusters within the dataset. From left to right, you can see the subclusters as they group together into subsequent hierarchical levels.
In this example, hierarchical affinity propagation was used to perform image segmentation by clustering groups of pixels based on similar colors.
The final goal for this project is to use cluster membership gained from hierarchical affinity propagation in combination with semantic metadata mined from the input data to create a rich, interactive user environment.
This simulation shows how our solution can present meaningful information about an initially unknown dataset in a portable and scalable web interface.
This has been the Big Data team from the Amalfi REU. We hope you now have a better idea of our start-to-finish solution of the problem of using machine learning analytics with big data. Thank you for your time.